Hello everyone, my name is Manan Maisheri.
Hello, myself Kavya Nayak. So, every scraper starts the same way. One empty box and you hope you paste the right thing in it. SpiderFix asks something first. What are you feeding me? A product page, a listing, a keyword, or a whole sitemap?
And each answer changes, both the input you get and the engine behind it. Sign in describes your target in a chat and row comes back as JSON, CSV or Excel.
Under the hood, SpiderFix runs a Next.js 14 with TypeScript. So the UI and the API routes are live together in one deployment. Data goes into Postgres on Supabase through Prisma. Authentication is our decrypt password hashes and a signed JWT in an HTTP only cookie checked through the Edge middleware.
Two storage decision cause trouble. Queries go through Supabase Pooler but migrations need a direct connection. So Prisma holds both URLs. And results over 64 kilobytes go to Supabase storage instead of Postgres. One sitemap run can be a megabyte while our database tier is only 500 megabytes.
Now for the demo, sign up is 3 steps and the Postgres dots and nodes in the web. In the console, I'll pick a category page and paste the URL.
And there we go, 20 rows with title, price, currency, image and position, pulled from a live page in about 2 seconds. We can switch between JSON and table view, then export everything with one click to CSV or Excel assets.
Now the expensive one, a whole site map with 5,000 URLs. Notice that change frequency is empty in every row. That's not a crash. It's SpiderFix telling us the site simply doesn't publish that information.
Every run is saved automatically, so if I open history, I can reopen those stored rows without scraping the site again. That gives us a repeatable record of what each run actually produced.
All of that was SpiderFix fetching pages itself. And that has a ceiling. It can't run JavaScript and a cloud IPs can get blocked. So let's try Amazon.
On our own engine, Amazon returns a 403 nothing. Now we send that same URL through Bright Data's web unlocker, which gives us a residential proxies, captcha solving and browser rendering. The result comes back live with all 11 fields populated, and it's batch Bright Data.
The important part is how little changed. Unlocker hands SpiderFix HTML and SpiderFix already extracts well from HTML. So exactly one function changed. Nothing has to be written for each scraper type.
Three things went wrong while we built this, and those failures taught us the most. First, our listing scraper kept returning the category sidebar instead of the actual products. We were choosing the biggest group of same shaped links, but a navigation menu can beat most product links.
We fixed that by scoring for stronger product signals, especially images and prices. Second, sitemap generation was taking 80 seconds because we were building an XML tree for 30,000 URLs. A bounded scan that stops at the cap brought that down to 2.3 seconds.
And third, deployment failed with a database URL, error saying it had to start with PostgreSQL. Even though it clearly did, the problem was a hidden byte order mark that PowerShell had appended to environment variable.
Building the scraper was the easy half, making it survive a real network, a pool database connection, and someone else's predictable HTML was the rest. That's why SpiderFix is really about not just extracting data but making the extraction reliable.
And that's the system running live today. 5 scrapers types a 5000 row sitemap cap, 32 saved runs, and more than 25,000 rows stored.
From a single pasted URL to structured data, with the option to write data when the site fights back.
That's
That's SpiderFix.
SpiderFix.